All right, today we are finally doing 5.1, and you'll see why I did not start off the semester with section 5.1, because it's something really different. And I think it's pretty cool, but it's a different way of proving something. It's proving something's true by proving the alternative is false. And so this is what we call an indirect proof. There we go. An indirect proof, sometimes called proof by contradiction. Let's look at this example. And you'll know when these proofs are because something's weird about them. So let's look at the given. The given, and this is where you'll see the difference. We're given that A is congruent to D, and we see that. And we are given AB is congruent to DE, so we can see that. But then the next bit of information right here is kind of weird. It says AC is not congruent. See how the line's through the congruency symbol there? AC is not congruent to DF. I don't know how I'm going to write that down. But what I'm going to do is this. We are going to prove the opposite of that. So if we can prove the opposite of that, well, you'll see. I'm getting ahead of myself. Finally, we need to prove, look at that. Angle A is not congruent to angle E. Well, that's just weird. How do we prove something's not congruent? Well, what we're going to do is we're going to assume the opposite. We're going to assume the opposite of that and then show that we have a problem. So this is the proof that's done. It's not the 2-column, but that's okay. We can reason through it, and we're going to do some examples. So what we do, and this is the key right here, when we do these proofs by contradiction, what we say is either these angles are congruent or they're not congruent, okay? We can't have anything else. They're either congruent or they're not congruent. It's one or the other. We have two choices. So because we want to prove they're not congruent, what we're going to do is we're going to assume, and these are key words that we're going to be using, we're going to assume that angle B is congruent to angle E. Okay? So we're going to assume they're congruent. And then we're going to show what happens if they are congruent. So from the given information, we have angle A congruent to angle D, side AB congruent to side DE. So if angle B is congruent to angle E, then we could prove that the triangles are congruent by ASA. And if the triangles are congruent by ASA, angle side angle, then that would be true. But we have a problem because we were also given that AC was not congruent to DF. So this is what happens. And these little 3 dots there, that means therefore. We mathematicians don't like to write. So we abbreviate whenever we can. So therefore, if the triangles are congruent, those two sides would have to be congruent. But then we say false, right? We scream false. It can't be, because we were given that they weren't congruent. And then we say thus or hence, our assumption was false, and that must be true. So therefore, those angles must not be congruent because it led to that contradiction. Wasn't that fun? So what we're doing here, when we do an indirect proof, we're going to start with either blank or blank. okay? And this is based on what we want to prove, okay? And then what we have to do is we are going to assume, assume blank. Assume the opposite of what you want, or not want, of what you are trying to prove. And then you just go along with it, right? And then at the end, you're going to have false, right? There's going to be a contradiction. Since we were given blank, our assumption was wrong. Therefore, blank. And you can use the 3 dots if you want to. So that's what these are going to look like. Let's try a couple of examples. All right, so we are given RS perpendicular to PQ. This is what we're going to end up contradicting. Okay. Ooh, I want to move this. I'm not going to do this yet. Now, we want to prove RS does not bisect PRQ. We want to prove that RS does not bisect PRQ. So, here's our proof. Okay, we're going to say either, and this is how they have to start for these indirect proofs, either RS bisects angle PRQ or RS does not bisect angle PRQ. Okay. We are going to assume the opposite of what we want to prove. So we're going to assume RS bisects angle PRQ. We have to write all of this down. You have to say either this or that is true. We're going to assume this. And then we go along with our proof. So that assumption we don't put in our proof, but we're going to use, maybe we'll do a different color there. Use like a given. So just pretend it's in the 2 columns. So here, our givens are RS perpendicular to PQ, PR not congruent to QR. Given. This is also given, okay? That's also our given. All right, so if we have perpendicular, then we can say angle PSR and angle QSR are right angles. And that's because perpendicular means we have right angles. So I'll put right angles for both of them. Now, remember, we're assuming RS bisects angle PRQ. So we can say angle PRS is congruent to angle QRS. And that's because angle bisector divides angle into two congruent angles. So I'm going to mark those here. I'm going to mark them maybe in pink. We got those. We got those. And then we have, trying to prove these triangles are congruent, we can say SR congruent to SR, reflexive. And so we have this. And so now we can say triangle PSR congruent to triangle QSR by angle side angle. Oh, I forgot something. Ooh. I'm gonna squeeze it in here. Angle PSR congruent to angle QSR. This is 2.5. And 2.5 over here, all right angles congruent. Because I didn't use hypotenuse leg, I had to say that those angles were congruent. So now, if those two triangles are congruent, then that means that PR is congruent to QR. But we have a problem, right? We have a problem. I need to reduce all of this. So I'm going to try to... There we go. Perfect. And so now we say false. False. We were given PR not congruent to QR. Hence, oh, you know what? Or we could use therefore, but, or the three dots. Our assumption was false. So hence, RS does not bisect angle PRQ. Okay, so then our assumption was false, and we say therefore, the other must be true. Because if RS bisected that angle, then we ended up with that contradiction. All right, finally, last one. Given circle O and AB not congruent to BC, so that's what we're going to contradict. We want to prove that angle AOB is not congruent to angle COB. So remember, we start with either angle AOB not congruent to angle COB, or angle AOB, OB is congruent to angle COB. We are going to assume the opposite of what we want to prove. We're going to assume angle AOB is congruent to angle COB. Remember, that is a given now. We stated it. It's not in our two columns, but it's just as if it was. It's just right above where we start our two columns. So that is a given. And so we can mark it. AOB congruent to COB. Those two are congruent. In addition, if you want to write it down here, you can do that too. And then we have circle O, and we have AB not congruent to BC. So that is all that we're given. Okay, so this is a circle, and things we look for in circles are these radii, right? So we know that OC is congruent to OA because they're both radii. So we can say that. We can say AO congruent to CO, and that's all radii congruent. And, oh, if we want to prove these triangles are congruent, we have a side, an angle, and now we can use BO congruent to BO, reflexive, and that can be our other side. So now we can say triangle AOB congruent to triangle COB, and that's by side, angle, side. And then if those two triangles are congruent, then we have AB congruent to CB by CPCTC. But we have a problem because we were given that they were not congruent. So false. We were given AB not congruent to CB. Therefore, or the three dots, angle AOB is not congruent to angle COB. So our assumption was false, so therefore the alternate must be true. And that's it. So these problems, they're easily identifiable because you often need to prove something is not parallel or not congruent. Something's not, and then you have a not in the given. Also, if it was a quiz or something like that, I would say do indirect proof or a proof by contradiction. So I would alert you that way as well.